This is the second part of the video for 9.2 and 9.3, and this particular video is going to talk about inequalities, specifically less than, with absolute value, and I'm abbreviating that. So I'm going to be looking at problems to solve that look like absolute value of x, let me push this up a little, push that over, less than 4, or absolute value of x less than or equal to 4. Those are still in the same category of less than. For a number to have its absolute value less than 4, I'm going to describe something and then I'm going to erase it. In a number line, if this is 0, the absolute value of 0 is 0 and it's less than 4. The absolute value of 1 is 1, it's less than 4. 2, absolute value is 2, which is less than 4. Here's 3, its absolute value is less than 4. And 4, its absolute value is equal to 4, so just on the other side of it, all of these numbers, including the fractions and decimals, have absolute values that are less than 4. But let's take a look at negative 1. The absolute value of negative 1 is 1, which is less than 4. So all of these are included. Negative 2, its absolute value is 2, which is less than 4. Negative 3, its absolute value is 3, which is less than 4. Negative 4, its absolute value is equal to 4, so it's actually everything over here. So what I've tried to highlight in a very messy format is that if the absolute value of some mystery number is less than 4, then that mystery number must fall between negative and positive 4. With the key word there being between. So I said I was going to erase that, and I am. Excuse me. Anytime you're dealing with a less than with an absolute value, then you're going to look at between. All right, let me clarify that. Whatever is in the absolute value, in this case it's just x, it is going to be between negative 4 and positive 4. Negative 4 is going to be less than x, and x is going to be less than 4. If instead it is less than or equal to, you're going to have x, and negative 4 is less than or equal to x, which is less than or equal to positive 4. I call these notations the between notations. You get less than symbols on both, and you're going from the negative to the positive of whatever the constant is. You will be talking in terms of something called intervals, and hopefully you've seen that before. But an interval is a way of describing a range on a number line, and you put the leftmost value first. You put the rightmost value second. That's all you do, is where it starts and where it stops. If there is no equal sign, you put them in parentheses. This one, it goes from negative 4 to 4. But because there are equals, we have to have a different way of saying it's from negative 4 to 4, but the ends are included. And the way we do that is to use this square bracket instead. This number line, and I've already alluded to it, is from negative 4 to 4. So it is all of these values, and we will use parentheses to say you don't include the endpoints. This solution on a graph still is from negative 4 to 4, but I do want to include the endpoints because it says to include them. So I will use those same symbols of brackets. We will still be isolating our absolute value, but we'll be thinking of these in terms of intervals and less than. Let's look at number 1. I'm sorry, in this group it's number 6. It says solve and graph. And we have the absolute value of x is less than or equal to 3. You need to remember that you're going to do the between notation. Take the negative of the constant, use your less than or equal to sign, put your x, less than or equal to sign, and the positive. So it is between the negative and the positive of the constant value. All right, you have the answer in an inequality on a number line. That would be from -3 to +3. It is all these values in between. Are the endpoints included? You look up here to see if equal is there. If it is, you use the square bracket. You find the bracket on your, for MyMathLab, on the actual keyboard to the right of letter P. In an interval, it is the left to the right. It is where you start and where you stop, and you use the same symbols that you've used in the number line. So your answer, you will be looking at a multiple choice of graphs. That's your graph. Then they will ask you to write it as an interval, and it would be like this. So you will write your answer as an interval, and you will identify the graph. Let's look at number 7. It says to solve and graph. And if you have your problem sets, it might make it a little easier to take these notes. We have x minus 5, close absolute value is less than 5. Every time you have absolute value with less than, you need to think between. Make sure that the absolute value is isolated. So you will start with -5 less than x minus 5 less than 5. This quantity right here is what goes between them. Now, as far as solving this, I need you to look at it as 3 parts. And you want x to be the value in the middle. To make x be the only value in the middle, just look at it, you would need to add 5. If this were just a single inequality, you would know to add 5 over here as well. But it's a 3-part inequality, so you need to add 5 over here. So whatever you do to get toward x in the middle, you do to 1, 2, 3 parts. That gives me 0. Copy down my less than symbol. Now I have x, copy down my less than symbol, 10. And I have the inequality answer in a number line. X is between 0 and 10, so it will be in here. And are 0 and 10 included? Look at those symbols. No, so you will use a parentheses. The interval looks just like the number line. It is from 0 to 10. Those are not included, so you'll have parentheses. You will find the graph that looks right, and you will type the interval. Number 8. We're asked to solve and graph absolute value of x plus 1 is less than a 5. So remember, this expression is going to go in between -5, write down the less than symbol, x plus 1, another less than, positive. It is between the negative and the positive of the constant. I like to do this. Oops. To get x by itself in the middle, you'll need to subtract 1. But if you do it in the middle, you do it out here, and you do it out here. That gives me -6. Keep your less than symbol. X, less than symbol, 4. There's your solution. Number line graph. Here's -6. Here's +4. It is between them. Remember the word between for the less thans. And this does not have equal, so you'll have parentheses. In an interval, it is from -6 to 4. It's always left to right, and they are both parentheses. So find your number line graph, type your interval. Let's look at number 9. Solve and graph. Absolute value 2x plus 1, close absolute value, less than or equal to 13. I look and notice this less than symbol. My absolute value is isolated, so I know that the expression 2x plus 1 falls between -13 and +13. So you're going to make sure that you put whatever this expression is between the negative and the positive of your constant, keeping the same symbol both times. To solve this for x, I would need to subtract 1, so do it to all three parts. -14 is less than or equal to 2x, less than or equal to 12. Divide by 2, divide by 2, divide by 2. That gives me -7 is less than or equal to x, which is less than or equal to 6. On a number line, that is between -7 and +6. But because it does have equal as part of it, I will use the bracket. Then interval, once you're looking at the number line, the intervals are easy. It is from left to right, -7, 6. Because they are included, equal sign over here, I will use brackets. All right, number 10, solve and graph. I have absolute value. All right, and I'm going to have to plug in. All right, I'm going to solve and graph absolute value. 5x minus 5, close absolute value, less than -30. Now I need to stop immediately because we've already said an absolute value cannot equal a negative. Well, if it can't equal a negative, it certainly can't be smaller than a negative, because absolute values have value that's always 0 or positive. So, now, let me stop. The value inside can be negative. We've seen that. But the absolute value of that quantity cannot be negative. So we stop. As far as a graph, if you had a number line, you might see numbers on it, but there would be nothing selected. So I'm going to call it an empty number line. And if somebody said, what about the interval? Well, there is no interval. So we would say there is no solution. Now let's look at number 11. This will address the last issue. Suppose I have absolute value x minus 3, close absolute value, minus 6 is less than or equal to -2. Before I can talk about the between, because right now I'm looking at it going, oh, wait a minute, absolute value can't be negative, but I can't even evaluate that yet because the absolute value has not been isolated. So I need to add 6 to both sides before I think any further. I have an absolute value of x minus 3, close, is less than or equal to 4. Now I can work on the problem, and I know that whatever this quantity is, it is between negative 4 and positive 4. So negative 4 is less than or equal to, here's my x minus 3, less than or equal to 4. Going to add 3 to all 3 parts. And I have negative 1 is less than or equal to x, which is less than or equal to 7. On a number line, negative 1, 7, it is between them, and it does include them because it says equal. In an interval, it is from negative 1 to 7, and I will use brackets. So as a little bit of a summary, if you have the absolute value of an expression and it's isolated and it's less than some number, then you take the negative of the number, less than whatever the expression is, less than the positive of the number. All right, so it goes between them. Then you may or may not have to solve a 3-part inequality. All right, that'll be enough for this video, and then we'll go on to the final part.